Greetings teacher, this is Shubham on behalf of Team 18. I'm going to show you a simulation of our project since it is not feasible to collect parts and create it physically and show it to you. So there is a simulation we are running a Ros core. As you can see in the screen, our terminal window is open and Ros core is running. Ros is a robot operating system on which we are going to create a map and navigate a robot through a simulated world. We are going to show you on the simulator gazebo. So the next step to this is to just create launch the world and the robot in it. So I'm going to just launch it using this command, uh, and the raw score is nothing, just the starting of the operating system, that is robot operating system. And then I'm going to launch a graphical interface tool to get the laser data and map it on an image, that is RViz. There it is. This is the graphical tool, and I'm just going to resize them to watch them simultaneously. After that, we would need another function to move the robot in the map, that is teleoperation. So I'm just going to launch it too, and now I can use my WSAD keys to move it in the simulated world, the robot. So as I press the W key, you can see the robot going forward in the gazebo simulator, as well as in the RViz. There you can see the laser data uh, forming, updating. So it is going to just uh, map it there. It is taking a little time, but it will slowly create a map out of it. It is not quite good at the moment. So the green lines, dotted lines, you can see are the laser data, and the white area is the free to move area for the robot, and the gray one is completely unknown. And black dotted lines are created as obstacles or walls for the bot. So the way it works is laser data sends the data, and when there is a value of 100, it maps a black dot there or a green dot to represent in real time, and the area in between robot and that dot is marked as 0, that is free to move area, and the gray area is completely unknown, that is -1, and it is just a graphical representation of that on a 2D map. These are just 0, -1 and 100 values. So let me just move around and improve the quality of map, then we'll meet after. Okay, so the map looks good enough to work with, um, and we should move to next step, that is saving it. So to save it, we are going to use another Ros command and save it with the name map, and just going to give this command, and it is done. So we don't need arrays anymore. We have created and saved a map. This is the half part of our pro- project, and after that we need to navigate our robot in that map. So we are going to launch Ros Navigation stack, um, and do some slam, that is simultaneous localization and mapping. So it will again be opened in Arways, and there you can see laser data as green dotted lines again. Also these AMCL particles are the particles. You can see green particles except the laser data. Those are just guesses for position and direction of a robot. Those are just random guesses, and the wrong guesses will be discarded as the robot moves around. So just reshaping it uh, according to desire. So we are just going to give an estimated pose um, of the robot with its direction. Now you can see it is roughly aligned. After that we are just going to give it a goal, and it will create a path automatically, that you can see it is getting updated continuously according to uh, where the robot is and its surrounding. And you can see the green dots. Those are just arrows, not dots, but those arrows are getting concentrated at the center. That is the error is getting low, and you can see around the obstacles there is a red inflation. That inflation is to as you can see, the path is just a line, so the path should not be created very close to any obstacle. So we need to inflate the obstacles uh, about half the width of our robot, so that uh, it won't create a path just near obstacle and get hit by it. So that is all for our project. We can and we can give it comments according to how we want it to move, and it will follow that path. Thank you. Hope you like it.